looks weird. Okay. All right. So that was the problem we just did, of course. Does anybody, I think everybody was good there. Make sure you get lots of practice with this. It is a new language you're learning, a new way of writing things out, right? And so you got to practice. Okay, so let's talk about ethers and alkoxy groups. An ether is going to be a functional group. It's going to be represented with R, O, and then another R. Now note when you have two different R's, that's going to be R, and then the next one will be R prime. If you had a third different one, it would be R double prime. Fourth, R triple prime, right? You can denote different groups by putting those primes. Now, anybody remember what R means? It's some carbon chain. We don't care what it is, right? Another way of saying that is residue. This is IA, inner chapter A. Okay. So alkyl groups can be the same or they can be different. It doesn't matter. These could be two methyls that's still an ether. Okay. They could be two cyclopropanes. Okay. It's still an ether. The rules for naming are going to be the same, but first we have to recognize which alkyl group has the longer chain because that's going to end up being our parent chain, right? And so that's going to be very important. So you need to make sure you recognize which one is your parent chain. Okay. Now, the alkyl group, the longer chain of carbon atoms, that's going to be your root or parent, right? And that's what you're going to name based off of. Okay. You may recognize that realistically, the IUPAC naming is always the same in all of these cases where you have to find the root first, right? Once you have the root, you can add stuff to it. Okay, so number one, establish the root. Alkane or cycloalkane that has the same number of carbons as the main chain or ring in the R is going to be assigned as the root. Name the alkoxy group. So you're going to then name that shorter chain that's off the oxygen as the alkoxy group. Okay. You'll remove the suffix "il" from the name of the corresponding alkyl group. So that cycloalkyl group that you're naming as not the parent, the shorter chain. And you're going to add the suffix oxy. So if you're talking about them all without a number involved, you're going to call it alkoxy, right? If it's one carbon off there, it's going to be called methoxy. If it's two carbons, ethoxy. Everybody got the trend there? Okay. Fantastic. If it was a cyclo, what would happen? Like, let's say we have a cyclobutane off of one side. Cyclobutoxy. Okay? So you just add the cyclo to it. Okay. Then what you're going to do is, again, this is going to be another substituent. It's just going to be added into your IUPAC naming. Okay? Let's go and look at some examples. So right here we have two methyl groups. So we'll take one of those. Typically people do the one on the left because it's the first one in reading. So, yeah. This is going to be methane for our root. And then we're going to add as our prefix name. This is a meth, right? We would normally add that as a methyl if it's a substitution. But it has an oxy. So it's methoxy methane. That's the IUPAC name for that. Okay. This is the common name, by the way. This is dimethyl ether. And what you do for the common naming is you literally just name the things that are on the ether as if they're substituents. So just substituent naming. So di-2-methyls off of an ether. The common naming actually made more sense. I like the common naming. It's faster. But, oh well. IUPAC disagreed with me. So this one right here, we have an ethane on both sides. So it ends up being ethoxy, ethane. If you were naming this using common naming, it would just be diethyl ether. Two ethyl groups, ether. This one right here, we look at these two sides. This one's the longer continuous chain here, plus it's cyclo, so it gains that equal numbers advantage. So that's going to be our parent root. That is going to be cyclohexane. In front of it, we're going to have to do 1, 2, 3 carbons. So that's propyl normally, but it's an oxy, right? And so we're going to go propoxy cyclohexane. You guys might want to try to say that with me, by the way. This can be a little tricky to say. So propoxy cyclohexane. See how you got to kind of prepare for it? Okay. Feel free to put breaks in if you need. It's better to put breaks and actually be able to understand what you're saying than to just like blurt and it make no sense at all. Okay. And if you're doing common naming, by the way, this would have been cyclohexyl, as if it's a substituent, propyl again, and then ether. All right, so let's talk about ethers that require locator numbers. So for example, right here, we actually are going to require a locator number because you have two options that this oxy group could have been attached to. And that's the first position here and the second position there. Notice that the third position would be the same as the first position, right? There'd be no difference. Okay. Excuse me. I have a real sore throat today for some reason. Okay. And so this one right here, that's the same sort of naming as this, but this one's the second position, isn't it? So again, our longest continuous chain is going to be the propane. Off of it, we will add the substituent, which is the methoxy group. And in this case, it's going to be on the second position rather than the first position. Notice you can have multiple ethers on a structure. And so this one has multiples of these ethers. They're actually the same ethers on different positions. And so our longest continuous chain is right here. That is the cyclohexane. We have two ethoxys off of this. That's ethyl right there, right? So ethoxy. And so that is diethoxy. And they are on the 1 and 4 positions. Which one being 1 and 4 doesn't matter. That you'd get the same name. Okay. Okay, is there any questions about that so far? Did I lose anybody there? No? Okay. Okay, fantastic. Let's go ahead and go on to the next. Let's talk about trivial names or common names. Trivial names is such a commitment to an opinion on this, by the way. The first time I ever saw this, I remember thinking, yeah, that's definitely something an IUPAC person would say. Trivial names. You know, the names that have existed for like hundreds of years. Trivial. So, the organic compounds were originally named based on properties or the origin of that compound. And so cybosable numbers of these have what are referred to as historical normally, but can be referred to as trivial names or common names that are regular in use. And in fact, if you actually totaled the amount of use all around the world, probably are far more used than the IUPAC names, in fact, because most chemical manufacturers have no idea how to IUPAC name at all. And couldn't care less. They're not changing their systems for some IUPAC name. So there's actually a numbering system that can be used to determine chemicals. And that's what, when you're starting ordering stuff and that sort of thing, you typically use that. Okay. In case you're wondering how this actually works in real practice. You look up the number system usually, and you order using that. So many non-scientists only know compounds by things like their trivial names. In fact, even scientists commonly just know them as their common names or their so-called trivial names. Like if you talk to the biology people on the floor, most of those things, they will have no idea what the IUPAC name is. Okay, at all. Like formalin, if you talk to any of the biologists, likely will not know the IUPAC name whatsoever if you mention it. Okay, because you just don't need it. why the hell would you need it? It's longer, harder to say. Nobody cares. Okay. So formaldehyde, for example, glucose, adrenaline, these are all examples of people know their common names or know their historical trivial names. They have no idea what the IUPAC name is. For honestly, I couldn't tell you what adrenaline's IUPAC name is without like going through and figuring it out. Yeah. It's very long and is not worth memorizing. So these are some different substituents that have common names, which you'll see used heavily and have actually made the transition to IUPAC naming. So, like, even if you look up the IUPAC name, you'll likely see isopropyl in that. It's not actually an IUPAC name. That's a common name. But, like, everybody puts it in the IUPAC names. So, this is a substituent. In fact, you've seen this substituent if you've ever taken any biology classes, because any of the like amino acids that say iso in them are isopropyls typically. So you've probably seen this a number of times and you didn't realize it. And that tells you how common that is, right? Yeah. Which it's not the IUPAC name, right? That would be methyl ethyl, right? That's the IUPAC name. Anyways, tert-butyl, another very, very common one. You've probably heard of like tert-butyl alcohol or butyl alcohol. That's what they're talking about. It just has an alcohol right here. Okay. Very, very, very common names that even if you looked up IUPAC naming, it's probably going to show up. Okay. Though it is not actually IUPAC naming. Okay. Anybody have any questions about that so far? Okay. So realistically speaking, most of this naming stuff is not like super conceptually difficult. That's why I mostly just like work through examples with you and show you all the different types of examples. The rest of this is a practice thing. Okay, so hit that homework. Make sure you practice through. Try those out. If you're having difficulties, you're getting stuck, come in and talk to me, okay? Or tutoring if you can't get my office hours to work for you. And just work through it. It's a language. You need to learn to use the language before you can actually learn anything else. Okay? Realistically, most science classes actually, if once you have the language down, you can at least interact with problems, and your rate of getting them right is going to go up to something like 40% at least, just from having the language, right?
I have a question.
Mm-hmm.
So whenever the isopropyl, whenever you have the like squiggly line, could be like,
Mm-hmm.
so on the homework it was like isopropyl chloride, and then one of the chloride where like that squiggly line is.
Mm-hmm.
Does that like line basically mean anything can be attached to it? Just has
Yeah.
to.
Yeah, that's actually a common name in that case. So if we're talking about IUPAC, the squiggly line is a parent chain. Okay, period. That's the root chain. And that's actually what it means. It's literally denoting that I have some number of this, as in like a line angle structure, right? So on IUPAC, it has a very specific meaning. But in common naming, because they took the common naming things into IUPAC, it can actually mean anything in common naming. Okay. Just whatever you attach to, period.
It just has like two methyl groups.
This, so this just means any chain at all. Oh, isopropyl. So isopropyl actually is denoting two methyl groups at the end. Yeah. So isopropyl, propyl means three, so you have to have only 3 carbons in there. But the iso part actually is just referring to this part. So you can have whatever length, and it would be the iso, and then butyl, hexyl, whatever. That actually just means it has this shape at the end. The isopropyl means 3. So. And so that can only be the 3. No problem. Did that make sense? Okay. Sometimes when I go long enough, I'm like, did that even make sense? Okay. So the propyl is because it's 3 carbons. Iso mean it's been restructured, so it's not a straight chain off of it. Hmm? So what we're looking at here is every place these lines ends, those are each carbons, right? So that's a carbon, that's a carbon, and that's a carbon. And so the propyl tells you 1, 2, 3 carbons. The iso tells you that it's methyl like that. Is that making a bit more sense? Yeah. That they're organized with this shape at the end.
How about the one that's attached to
Tert is telling you that it's fully carbons around it. And then butyl is it's 4 carbons. So the structure is this tertiary is actually what it stands for. That has 3 carbons off the end. Okay? And that's the tert carbon. And then the fact that it is 4 carbons total is the butyl. That making sense? And again, you can have a tert hexyl, tert decyl. Yeah, so this is a substituent, and it's one of the alkyl functional groups. Yeah. And so this is just going to be a substituent on some longer parent chain typically. Though when you're talking about common naming, this could have like an alcohol over there. Because in common naming, you can use functional groups as parent chains. Yeah. But in IUPAC, it's a parent chain on the other side. There's some longer continuous chain that's not part of, right? Is that making sense? Okay. Everybody got it? Okay. Any questions? Yeah, again, this is one of those classes that realistically speaking, my lecture will like have the key points. I'm more trying to front load you for when you do the homeworks. And that's when things should really start locking in. Okay. Without the practice and you practicing pretty much immediately after we're done here, you're going to lose the vast majority of this. Okay. It would be like trying to learn a language where you never say anything. It's going to do you 0 good. Anybody ever done that? Nobody's used the Duolingo or anything like that? Like, what does Duolingo do? Tells you the language thing, right? And then you say it, right? Okay. So, like, you got to use the language. Don't forget to use the language and do the homeworks right away, okay? Like tonight at latest. Do some sort of practice with it. Otherwise, it's all gone and you just waste time. Mm-hmm. This is IA. Yeah, so inner chapter A. All the naming stuff they're referred to as inner chapter. And there's IA, A, B, C, D. And then we'll get through basically all the primary naming rules. There are supplemental ones, but we won't cover them in this course because you guys just never will need them. It will take me a tremendous amount of time. I probably am not going to have enough time to do that. And due dates sometimes change. What you can do, however, is you can actually take your calendar and just mark off when things are due. Because I do shift assignments when we need to. So, unfortunately,